Right, so the problems with question 1. First one was caused by me because when I typed this out, I'd had that as 0.2, and then I came into the exam hall and said it's not 0.2, it's 0.25, and some of you changed that probability to 0.25, not that one. So for those of you that made that mistake, I then did a separate mark scheme to see if I could apply that. The second common mistake was to try using a probability tree. So I'll show you first up why using a probability tree wouldn't work. So Football Manager is aiming to buy 2 players in the transfer window. He estimates that the probability of buying player A has a 0.2 probability and a probability of 0.7 of buying player B. He believes he has a 15% chance of buying both. Now, if you were to set that up as a tree diagram, so you'd have buying A, not buying A, buying B, not buying B, then buying A is 0.2, 0.8, 0.7, 0.3, 0.7, 0.3. So the probability of buying both would be that one and that one. So A and B would be 0.2 times 0.7, which is 0.14, not 0.15. So if that came out to be 0.15, that would be fine. But it doesn't, so that approach doesn't work because of the test of independence. So we'll rethink it, and we'll rethink it as a Venn diagram. So we've got probability of A, probability of B, universal set. He believes he has a 15% chance of buying both, so that means that our intersection is 0.15. Now if our intersection is 0.15 and the probability of buying A is 0.2, the full circle is 0.2, which means the chances of you only buying A is going to be 0.05, so that adds up to 0.2. And similarly for B, probability of 0.7, the whole circle is 0.7. Take 0.15 off that, gives you 0.55. Show that the probability that he isn't successful at buying either player is 0.25. But if he isn't successful, then that's the region outside the circles. So A, probability unsuccessful, will be 1 total probability less those. So half term, my brain's gone to sleep. So 1 minus open bracket 0.05 plus 0.15 plus 0.55 close bracket equals 0.25 as required. B, the probability that he buys exactly one of the players, well, that means he's either only going to buy A, which is that, or he's only going to buy B, which is that. So probability would be 0.05 plus 0.55 equals 0.6. And then we've got a conditional probability. The trigger is the given that. Given that he does not buy player A, find the probability that he is successful in buying player B. So the probability of him buying B, given he's not buying A, so So using the conditional probability rule, that's the same as the probability of buying B and not buying A over the probability of not buying A. So buying B and not buying A means he's only buying B, which is 0.55. And the chances of him not buying A is going to be 1 minus the chance of him buying A, which is 0.2. So that will be 0.55 over 0.8 which is 0.6875. So that's question 1. So again, the main mistake that was made was trying to go down the path of the probability tree, which doesn't work because of that test for independence.